Okay, we're going to pick up where we left off. I definitely want you to know how to do one like 31. All you have to do is multiply each one of these things by that denominator. Because if you multiply everything by my denominator on number 31, you'll be left with an equation that has no denominator. Right? Because those are going to divide out. And so now, and you would do the same thing, like on this one, you would multiply everything by 4a. And on this one, you would multiply everything by x plus 5, x minus 3, because that is x plus 5, x plus 3, I'm sorry, I said it wrong. But on this one, once I get my fractions gotten rid of, now I just have an equation where I want to try to move all my x's to one side. So I get negative 72 equals 4x, or as I like to write it, 4x equals negative 72. So now, just a matter of dividing by 4 is going to get me to that final answer of negative 18. All right, definitely make sure you can do GCF factoring. Like here, you know 6 goes into both of those, but you got to take the smaller exponent. And so here you're going to be able to factor out 6x to the 5th, which leaves you with x squared minus 8. Same thing here, 27y cubed minus 6y squared plus 12y. It looks like to me everything is divisible by 3. And y, because I got to take the smallest. So that would be 3y times 9y squared minus 2y plus 4. And then on this one, these two terms have t squared minus 10 in common. So you would pull out the t squared minus 10, leaving you with s plus 2. But, you know, that's a good one to know how to do. Same thing on ones like these. This is just a simple what multiplies to negative 12 and adds up to positive 1. And that would be 4 and negative 3. So that's just x plus 4, x minus 3. On the next one, don't forget, if you can divide out something, like here I can divide out a 4, right? So this becomes 4 times x squared plus 3x minus 10. And so now it just becomes what two numbers multiply to negative 10 and add up to positive 3. And that would be positive 5 and negative 2. But notice that 4 I took out just comes along for the ride. That's how that works. And then on this one, guys, it's just an x at the beginning and a y at the end. But you're still going to do your numbers, right? This would be 4 times 8. And so x plus 4y, x plus 8y. All right, the next grouping should be Claudia's method, right? This is Claudia's method. So you're going to have to, like on this one, you're going to bring this number back. So I'm going to multiply by 2. So I end up with the equation x squared plus 23x plus 22. And so the two numbers that do that are 1 and 22. So x plus 1, x plus 22. And now I've got to divide that 2 out. And so if the 2, if you have a fraction that's reduced, you're going to bring that denominator up in front of the variable. So this one becomes 2x plus 1. And then 22 divided by 2 is just regular old 11. So there you go. Same thing on this one. I'm going to bring the 3 at the back so that I end up with, sorry, I wanted that to be that color. Yeah, just a little bit neurotic. So here I end up with x squared minus 7x minus 18. And so if I think long and hard about my numbers, right, negative 18, negative 7 will be negative 9 and positive 2. But now I've got to divide that 3 out. And so here I'm good. It's just going to be 3x plus 2. And here it'll be x minus 3. All right, moving along. Okay, so these are solved quadratic equations by factoring. The other night when I did this in my class, I actually added a number to number 43. So I'm going to change this to 16n squared plus 48n minus 64 equals 0. And the reason I'm doing this, guys, this is like the one on your test. Because on your test, what happens is there's a GCF. So the first thing you would do is you would take that GCF out. And if I do that, then I have n squared plus 3n minus 4 equals 0. Oops. Yeah. Which, lo and behold, this is easy to factor. Negative 4 and positive 3 would be a positive 4 and a negative 1. And so what's different here is I'm not just factoring it, but I'm solving it, right? I've got that equals 0. So because I have that equals 0, I'm going to set each little factor to 0, and then I'm going to solve. So if n plus 4 is 0, that means n is negative 4. If n minus 1 is 0, that means n equals 1. Okay, so those are my solutions. And so that's what you would do, you know. Similar thing up here, set this to 0, factor it, set each factor to 0, and solve. Let's move on. Okay, these exponent ones are easy. On number 46, this is all multiplication, right? That's 2 times x times 7 times x squared times x cubed. The quickest way to do it is to recognize you've got numbers you can multiply together, right? So you have 2 times 7, which is 14. And then you've got x squared, and x cubed. Well, this is a 1 here. So you have a total of 1 plus 2 plus 3, which is 6. However, if you needed to, you could always reorder. And if you want to double check, remember that's x squared is x times x, and x cubed is x times x times x. And plus you have that other x there, right? So lo and behold, you do get that total of x to the 6th. All right, so this was an add exponents exercise. Here is a multiply exponents exercise. So I'm going to multiply my exponents inside the parentheses by negative 2. So all of those get multiplied by negative 2. So I have 4 to the negative 2, x to the positive 12, and y to the negative 2. Now, do not leave any exponents negative. Well, what's happening here is to make these negative exponents positive, that one's already positive, I'm going to put them where they ain't, and they ain't in the bottom. And there's one more thing I can do here because 4 squared is 16. So there you go. Um, 50 and 51 look better to me. The main thing on 51 that you want to remember is it's going to be much easier to take this subtraction, and instead of leaving it like that, what I would do is I would change it to adding, but then I'm going to change all of my signs, meaning this is going to be negative 10x cubed, negative 3x squared, positive 2x, and positive 3x to the 4th. Right? So 51, I'm just kind of for a second. So all together now, my first one was x to the, I'm going to put this in order. That's the other thing I would do, guys. But it's just combining like terms. So if I put this one in order, I would have 6x to the 6th plus x to the 4th minus 7x cubed minus 14x. So that's my top one. And then plus, and then I'm going to put these in order here. So minus 3x to the 6th plus 3x to the 4th minus 10x cubed plus 2x. And now all I have to do is combine like terms, which just basically means to add those coefficients, right? That's a 1. Here you get negative 17, and here you get minus 12x. That's how I would do it. There's a couple of ways you can do it. The main thing to remember is you're subtracting everything in that second set of parentheses. God, there's so much background yelling here. All right, and I erased it, but I do want to look at number 51. 51, you've got your options of the two ways that I showed you guys. The way that I like to do it is by setting it up like old school addition. Some people like to do this. They prefer the arrows, the old way that most of us learned how. Like this. If I do my minus 4 first, I'd have minus 28, minus 4x, minus 36x squared. Sorry about that. And then if I do the x on this one, I get plus 7x plus x squared plus 9x cubed. And so multiplying it out long way, I get this, and then I'm ready to combine my like terms. If you did it this other way, when you multiply everything by x, you would get 9x cubed plus x squared plus 7x, and then minus 36x squared minus 4x minus 28. Still the same pieces, right? It's just that here you have to kind of look to get it lined up. But on mine, they're already lined up. So here I don't have to sift through to find those two. It's just there. So that's just minus 35x squared. It's still the same thing over here. Then you've got 7x minus 4x, which is positive 3x, I'm sorry. And then the minus 28 is what's left over. So make sure you can do one like that. These are bad, guys. Because you're dividing by one term, then you're allowed to do this. And so by this, I mean I'm going to be taking one of my x's out of the exponent. So this would be 3x7 minus 4x4 plus x. That is literally it. The same thing here. 36x to the 8th power divided by negative 4x squared. Well, 36 divided by negative 4 is negative 9, and here I'm taking out 2. So I drop it down to x to the 6th. Then plus 40x to the 5th divided by negative 4x squared. Well, 40 divided by negative 4 is negative 10, and then if I subtract my exponents, I get x cubed. And then last but not least, on this last one, you end up with positive 7 when you divide, and there's no more x's left. So that's how you deal with that one. I'm right by a coffee machine. It's great. Is that really how far? Well, that's not how far we are, is it? I skipped something. Oh, wow. Good. All right. To graph the linear equation. Okay, I'm back with the graph. If you were going to do this one, the easiest way to do this problem is to do an XY table with 0 for x. Try 0 for x, and then you get y equals 2. Because if x is 0, this whole thing is 0. And the equation 3y equals 6 means y is 2. Then if I plug in 0 for the y, then I have 2x equals 6, which means x equals 3. So I've got the point 0, 2, which is right here. And then the point 3, 0, which is right here. Draw my line. I'm done. Y equals negative 3. Since there's no x, that's just a horizontal line through y equals negative 3. Okay. Now, if you actually use the slope-intercept form like it is on this last one here, then in this problem, you start, when you have y equals mx plus b, you actually start with b. So the first thing I'm going to notice here is b is negative 3. That means I'm going to put a dot right here where b is negative 3. Then the second thing I'm going to do is I'm going to notice M was positive 5/4. So that means from that point I just plotted, I'm going to go up 5. So I'm going to rise 5. And then I'm going to go right, or I'm going to run 4. So I'm going to rise 5. Rise 5. 1, 2, 3, 4, 5. So I want you to notice how there's literally 5 blocks here, if I were to shade them in, right? 5 blocks up. And then I'm going to run 4, which means I'm literally going to go 1, 2, 3, 4. And that is where my second point is going to live. And so now all I have to do is draw the line between them. So all I had to do was rise or go up 5 blocks and then right 4 blocks to get me to the next point. And you just have to start at your B value. You have to start with B first. All right, the last ones are easy. First thing I will say, why does that keep happening? I don't even know what that is. I've never even seen that. Oh, that's weird. Okay, first thing I'm going to do is number 59. Those divide out, guys, and you're just left with y minus 3 over 5, y plus 5. Don't overthink that. Number 60 is a cross multiply one because you have a fraction equal to a fraction. Anytime you have a over b equals c over d, then you could do a times d equals b times c, which in this case would be 2 times x minus 2 equals 3 times x plus 3. So if you notice here, I did those two here, and then I crossed it with those two. And that becomes 2x minus 4 equals 3x plus 9. So I'm going to, it doesn't matter what steps I do here first, but I'm going to take 3x away from both sides, which would give me negative 1x minus 4 equals 9. And then I'm going to add 4 to both sides. So that means negative 1x equals 13. But I don't want negative 1x, I just want x, so I'm going to divide by negative 1. And lo and behold, x equals negative 13. Now, some of you would have gotten to here by subtracting 2x first, and that would have been fine. But that's how you do that one. And then for number 58, I kind of skipped over it. But all this is filling out an XY table. So on number 58, they've given me the x values. They've given me 3 points with x values, right? So if I make an x column, then I'm going to put these values in my x column. All right, and so then the output, the y values, are going to be dependent upon the equation negative 4x minus 31. And so I'm just going to plug those values of x into my little formula here, and it's going to tell me what those y values are. If I can write nice. -4, So I'll plug in negative 31, negative 9, and 0. And so, lo and behold, if I multiply here, I get 124 minus 31, which I believe is 93. And then for the next one, I get 36 minus 31, which is 5. And then on this last one here, I get 0 minus 31, which is negative 31. And so we get 93, 5, negative 31. And those are my solutions for that problem.